This lab is called determination of ideal gas law constant, but we are not going to finish the whole lab, and we are not going to calculate the ideal gas law constant. So I make some big changes to the lab. You don't need to calculate the ideal gas law constant, and please follow the instruction in this lab and use the data table in the worksheet for the homework. You only need to do activity 1, try 1 to 6. The main purpose of this lab is to learn an important skill, collecting gas over water. We need to run a reaction. It's the decomposition of hydrogen peroxide. It will generate water and oxygen, and we will collect oxygen over water. For this experiment, we need a catalyst to speed up the reaction rate. And here we use catalase. It's an enzyme from yeast, serve as the catalyst here. And remember, a catalyst is not consumed and is not altered in the reaction, so it has no effect on the products or the reactants. In other words, the amount of the catalyst won't affect the amount of the products generated. More catalyst won't give you more product. Smaller amount of the catalyst won't lead to a lower yield. As long as you don't pour a large quantity of the catalyst or just a super tiny little bit of the catalyst, a reasonable amount of the catalyst will work, but you don't need to be very exact. You can find these 3 items from the experiment kit, and the yeast is actually in a different packaging. The hydrogen peroxide is a quite large bottle from the large chemical kit. The following items can be found in the large experiment equipment kit bag, and of course you also need water. To start, first you need to determine the air temperature using the thermometer. Just put the thermometer on a table or anywhere that's close to you, but make sure the bulb of the thermometer not touching any surface, so it's measuring your surrounding air temperature. Second, you need to set up the gas collection apparatus. This is very important, and the lab manual also provides you a detailed video, so I'm not going to repeat the process here. Please watch the video there, and you can practice several times until you get a good apparatus, and then you can proceed with the reaction. It doesn't show clearly here, but just let you know that you need to connect the tubing to the stopper first. It's hard to insert the tubing all the way to here. Maybe you are very strong, you can do that, but I can't. It's okay. As long as it is tight enough, it will work. And before I flip the graduated cylinder, I like to make it full of water. You see here the water is almost flowing out of the cylinder. It's holding there because the surface tension. So I like to make it full and then put my thumb on the opening and quickly flip it and insert it into the beaker. As long as the opening of the graduated cylinder is under the water level, you can remove your thumb. This step will have, you will spill some water during this step, and that's okay. And once you flip it, if no gas is present in the graduated cylinder, you can record the initial volume as 0. But if you accidentally get some gas coming into the graduated cylinder, don't worry about that. You can also just record whatever amount of the gas as your initial gas volume. Here, the large marking is 1, this is 2, this is 3, and the smallest marking is 0.2 ml. So here I have about 0.4 ml. It's kind of hard to read the readings from when it's upside down, and also it's kind of tilted because of the tubing at the bottom. But try your best to get a best estimation. Once the reaction starts, you will see bubble coming in and the water level decrease. Let's say it decreased to this marking and stops. Then you can record the final volume as 2 ml. And for delta V, simply subtract 2 ml from, subtract 0.4 ml from 2 ml. That's 1.6 ml. And that's your delta V. So to start the reaction, you need to weigh the yeast first and pour the yeast into this small bottle. And then measure hydrogen peroxide. Let's do 1 ml first. Pour it into the small bottle and quickly snap the dropper top with tubing onto the bottle. It won't be very stable. I would suggest you use your hand to hold this stopper and the bottle so you don't knock it down. And once the reaction starts, you will see the gas coming into the graduated cylinder. Make sure all the tubings are connected well, and allow the reaction to proceed until no additional gas has been generated for at least 1 minute. And then we can call it the end of the reaction, and you can record the final volume of the gas in data table. After the reaction is done, you can remove the top of the bottle, the top stopper from the bottle. Pour the contents down the sink and rinse the bottle 3 times with water to remove any residue. And then repeat these steps using 1 ml hydrogen peroxide again. And then repeat the activity with 2 ml hydrogen peroxide twice and 3 ml hydrogen peroxide twice. And then use data table in the worksheet to record your readings and do a little calculation here to get the delta V, which is the volume of the oxygen generated by the reaction.